areas and definite integrals. Areas and definite integrals. So we say if a function f is continuous, means no gaps, no jumps, no holes, on a closed interval AB, and capital F is the antiderivative of the function f, then we have the integral from a to b of f of x dx can be calculated using f of the upper bound b minus f of the lower bound a. This is in calculus called the fundamental theorem of calculus. So if they ask us to find the integral from 1 to 3 of x dx, 1 to 3 x dx, how do we do this? Well, we integrate x first, as we did in 2 sections ago. So it's x squared over 2. You add 1, divide by the same number. And then look what we do. I'm going to put here a line, a vertical line, x equals 1 to x equals 3. So then it's 3 squared over 2 minus 1 squared over 2. So that makes it 9 halves minus 1 half, which is 8 halves. And that gives us 4. That gives us 4. So you can graph it as we did in the previous section and use the geometric way for that to calculate it. But here it's much faster. I don't have to graph. I don't have to find the areas, use geometry or anything like that. We go straight, integrate it, and then evaluate. Another example, 0 to 10, 3x squared dx. To graph this one is not going to be easy to find the area below the curve because it's not like a triangle or rectangle or trapezoid or something we're familiar with. So the first step we do here is we take the 3 out, 0 to 10, x squared dx. X squared dx. The integral of x squared, what's the integral of x squared? It's x to the third over 3 from 0 to 10. From 0 to 10. The 3's cancel out, so you substitute the 10 in first. So you always substitute this x first, then this one second. So always minus 0 to the third. So that gives us 1,000. Gives us 1,000. Integral of x squared plus x dx from 2 to 3. From 2 to 3. So how do we do this one? We can integrate them even if you don't want to split. The integral of x squared is x cubed over 3. Integral of x is x squared over 2 from 2 to 3. 2 to 3. Now, how are we going to do this one? Look what I'm going to do. I'm going to open parentheses separated with a minus sign. I'm going to substitute x equals 3 first. So 3 to the third over 3. 3 squared over 2. Substitute the 2 next. 2 to the third over 3 plus 2 squared over 2. Then after that, what we do, we get 27 over 3 plus 9 over 2 minus 8 over 3 minus 4 over 2. Then you can do the ones with the same denominator. 27 minus 8 is 19 over 3 plus these two together, 5 over 2. Then multiply by 2 by 2 by 3 by 3. 38 over 6, 15 over 6. And that would give us 53 over 6. or if you divide it, it's 8.883. Either one is fine. You can leave it as a fraction if you like. So now is the time for you to try one on your own. X squared plus 1 dx from -1 to 2. -1 to 2. You can move on with this. Integrate the first one is x cubed over 3 plus x from -1 to 2. And as I said, before you start substituting, make sure you open parentheses like this. Let's see. Substitute the 2 first for x, then -1 for x. And this gives us 8 over 3 plus 2 minus -1/3 minus 1. If you multiply or bring this down, plus 2, multiply the negative n, multiply the negative n. What does that give us? This is 9 over 3, which is 3, and 2 plus 1, 3. So the answer is exactly 6. No decimals. If you want to look at it graphically, what it means, what does it represent? It's the graph below the function y equals x squared plus 1. X squared plus 1, if you graph it, let's say using Desmos or a graphing calculator, this is y equals x squared plus 1. And we were integrating from -1 to 2. So that gives us the area of the yellow region, the 6. So the area of this shaded region is exactly 6. Although it's not a triangle, not a square, but we were able to find the area of the shaded region to be 6. That's exactly 6. Now we're going to look at another example here. -1 to 1, integral -1 to 1, x squared minus 1 dx, which is very similar to the previous example. So what we do here is integrating this x cubed over 3 minus x from -1 to 1. And let's see what we get for this one. Open parentheses with the minus sign separated. Substitute the 1 in. 1 over 3 minus 1. -1 cubed over 3 minus -1. That gives 1/3 minus 1 minus -1/3 plus 1. And what does that give us? 1/3 minus 1 plus 1/3 minus 1. So that's 2/3 minus 2. So the answer is, multiply by 3 by 3, -4/3. You might say, wait, there's a negative sign? How can an area be negative? Right? How an area can be negative? Well, let's try to graph that function on the side. Y equals x squared minus 1. It should be down this way. And this is really -1. This is 1. If you draw this on Desmos and click on these points of intersection with the x-axis, it will mark it for you -1 and 1. So what I just did, I found the area of this. It gives me -4/3. So the negative sign indicates, doesn't mean it's wrong or something went wrong. Negative sign in the answer here, negative sign indicates that the region, that let's say the majority of the region falls below the x-axis, falls below the x-axis. If not all, at least most of it, like more than half. If more than half falls below the x-axis, then the answer will be negative. Now the question people ask, can it be negative, positive, or 0? Yes, the answer yes, it could be any of the 3 cases. So which one of them, which you think is going to be positive, negative, or 0? Which one? So let's say this is the graph of a function, any function f, or something like this. So call this A1, A2, area 1, A2. This is A for area, or A1, whatever you like to call it. So area 1, because the majority of the region is above the x-axis, so this part here is is more than the dotted one, as you can see. So I expect when I calculate A1 is going to be a positive number. A1 and A2 are the same. They are same region. So what happened, A1 is going to be negative, A2 is going to be positive. But to find the area, the whole area, you add them up, A1 plus A2. And guess what? It's going to give you 0. Doesn't mean it's wrong, it's just they cancel each other, one positive, one negative. And they are symmetric, so they cancel each other. Another application in this section, find the area of each region. Like they give you the graph and you want to find the area. Number 1, so we are required to find the area of the shaded, and then the area here of this shaded. This, the function is y equals 2, horizontal line, y equals 2. So the area would be the integral from 0 to 3, always on the x-axis, 0 to 3 of 2 dx. And if I want to do not the geometry way, but the calculus method, you take the 2 out, the integral of dx is x, from 0 to 3. Open 2 parentheses with a negative sign. Substitute the 3 in, then the 0 in. So that gives you 6 minus 0 is 6. And you know it's 3 by 2 rectangle, it's 6. But I had to use the geometry, the calculus method. Same thing we do with the next one. The area is the integral of that function, which is x squared given to us, from 0 to 2. Now we integrate this x cubed over 3 from 0 to 2. Substitute the 2 in, substitute the 0 in. That gives us 8 over 3. 8 over 3. Evaluate a function. The integral of 1 over x dx. This is just more practice. 2 to 5. 2 to 5. How do we do this? Well, you know the integral of 1 over x from 2 sections back. It's natural log of the absolute value of x from 2 to 5. If you substitute the 5 in and then the 2 in, you get natural log of 5. You can drop the absolute value of 2, and if you calculate this out, I get 0.916. Put it in the calculator. Next one, if we need to calculate more, integral -5 to -1, same function. So again, this same thing, absolute value of x from -5 to -1. The difference is just there's negatives involved here, minus natural log of -1. So the absolute value cancels the negative in each one of them. And if you put that in the calculator, oh wait, I put -1, it should be -1 first, then -5. So it's 1 minus 5. This is 0 minus natural log of 5. Which gives me -1.609. For the next one, I can take the 2 out, dx dx from 0 to 3. And we learned 2 sections back the integral of ex is ex from 0 to 3. All we have to do, substitute that in. 2e to the third minus 2e to the 0. 2e to the third. 2e to the 0 is 1. And if you put that into the calculator, that gives about 38.171. 38.171. Number 4, the integral from 1 to 4, square root of x plus 1 dx. Square root of x plus 1 dx. Again, we can integrate this by rewriting it as x to the 1/2 first plus 1 dx. So this is x, the 1/2, you can add 1 to the exponent, you get 3/2 divided by the same number plus 1, from 1 to 4, from x equals 1 to x equals 4. This one you can flip it, becomes 2/3, x to the 3/2 plus 1, from 1 to 4. And all you have to do is evaluate this now. Evaluate it. Open in 2 parentheses, substitute the 4 in, 4 to the 3/2 plus 1, substitute the 1 in, I get 2/3 1 cubed plus 1. So if you put that into the calculator, 7.66. Now, as an application, this pure water thing finds out that the marginal profit in dollars from drilling a well that is x feet deep is given by p prime of x equals the 5th root of x. Find the profit when a well is 250 feet deep, is drilled, or 250 feet deep is drilled. So what's p of x? That's what the question is asking. So how do I find p of x? I want to go back. I want to go backwards. So they give me p prime of x. P prime of x is the 5th root of x. To get p of x here, I have to integrate both sides. But when you're integrating both sides, they are talking about the depth of the well. It goes from where to where, the depth. It's 250 deep, so it goes from x equals 0, the depth, to 250. 0 to 250. Now the left hand side, nothing but p of x that I'm looking for. This one, to integrate this one, we have to rewrite it as x to the 1/5 dx. X to the 1/5 dx. Then integrating this, add 1 to the top, becomes 6/5 and flip it, 0 to 250. Substitute the 250 in, 6/5 minus 0 in, 6/5. So this is gone. If you evaluate this on the calculator, it gives us about $628.56. One last example. They give us a graph x with shaded region t. This is the time, in hours. This is the velocity in miles per hour. Explain what the shaded area represents. I think that's what we started with either in, I think the last section, the previous section. You have time and velocity. If you multiply them together, it gives you the distance traveled. So the shaded region represents the total number of miles traveled in T hours. That's what this represents, total number of miles traveled in T hours.